Okay, so section 6.2, video 2, so we continue with one-to-one functions and their inverses. So let's start with the example. Let's start with the problem. Your textbook on page 420. You can read and go over problem 39. This is what we're going to do first. You have original function f of x, which is equal x to the third power minus 8. And you have function g of x with the equation of cube root of x plus 8. And what they ask you to check, so this is going back to the previous video, hopefully you guys watch it by now. They want you to verify, so again, they ask you to verify that f and g are inverses of each other. And they asking you to find the domain of each function. Because they want you to exclude the x values for which the function won't make sense. So I'm going to start with the domain. So function f of x, cubic function, x cubed minus 8. Cubic function, we talk about this function, domain, it's all real. So there's nothing to worry about it, okay? Function g of x, which is the cube root of x plus 8. Also, for this function, the domain, it's going to be all real, okay? When you have a cube root of index 3, under that root, you can put any number, 0, positive, negative, doesn't matter. You always will be able to evaluate. So we need to verify that f and g are inverses of each other. So first, we learned the theorem that if they are inverses, create the composition f composed with g of x and show that that will give you x. So we create that composition. Inside of function f, we plug in function g, which have equation cube root of x plus 8. So if f is outside, I copy the equation of outside function, which was x to the third power minus 8, and I'm going to replace x with equation of function g, which is the cube root of x plus 8. So what we're going to do, you have cube root and exponent of 3. So they are under each other. Okay, so that will cancel, and you will just end up with x plus 8 minus 8 cancel. This is equal to x. So we prove it. We show it that f composed with g will give you x. Next, you also have to show that g composed with f of x also will give you x. So we need to show that. So g is outside. Equation of function f is x to the third power minus 8. So what we're going to do, we're going to copy the equation of function g, which is cube root. And where we used to have x, we're going to plug in function f. So we have cube root of x plus 8. So where we used to have x, we're replacing x with function f, which is x to the third power minus 8. And we're going to simplify. So this is cube root of negative 8 and positive 8 will cancel. So we have x to the third power. And again, index and radicals, if they are the same, they always undo each other, they cancel each other. So that will give you x. Okay, so I think we're good with those type of problems, and we can move on to the next concept. Okay, next, let's talk about the theorem. The graph of one-to-one function and graph of its inverse function are symmetric with respect to the line y equal x. So, very important theorem, but again, I want to go back here. When we were proving that functions are inverses of each other, and of course they both are one-to-one, we were showing that the composition of both of them will give you x. Okay, so we were showing this already. So why they have to be equal to x? Because if functions are one-to-one, original function and its inverse, they're always going to be symmetric with respect to the line y equal x. Y equal x, we also call that function identity function, okay? So this is very important, okay? So let's just quickly show you that on the graph. So we have, let me just draw the best I can. So we have function f, okay? So this is function f. And identity function, it's the line y equal x. So y equal x, that's the straight line which goes through the origin. And again, you will have points 1, 1, 2, 2, 3, 3, that's the point of graph. So this is y equal x. So if I need to draw the graph of inverse function, so again, that graph will be symmetric. Too much. Be going that way. Okay, so that will be inverse. I'm trying my best, okay? This is the inverse. So like you see, those graphs should be symmetric with respect to y equal x. Okay, so let's do one example using that theorem. I'm going to use your textbook. I'm going to page 421. And this is exercise 45. The graph. So if you guys have a textbook in front of you, you don't need to copy this part. The graph of one-to-one function is given. Draw the graph of the inverse function. Okay, so again, on my MATLAB or on the test, I will try to select the problems where you just have to match the correct answers. So it will be easier for you guys. But this is what is given in this problem. Okay, they gave you the graph of function f. Function f of x. Let me just list the points which they give you. So some of the points. They give you point 1, 2. They give you point negative 0, 1. Negative 1, 0. And also they give you point negative 2, negative 2. So 1 comma 2. Then 0 comma 1. Negative 1 comma 0. Negative 2 comma 2. I'm sorry, negative 2. Okay. And you have to draw the inverse function. So inverse function, what I recommended, just switch the order of original coordinates. So inverse function will have point 2 comma 1, 1 comma 0, 0 comma negative 1, and negative 2 comma negative 2. So 2 comma 1, 1 comma 0, 0 comma negative 1, and negative 2 comma negative 2. Okay, so this is the inverse. And like you see, they're supposed to be symmetric with respect to the line y equal x, which is the straight line which goes through the origin. That's why the point negative 2 comma negative 2, it's on that identity line, which is y equal x, because has identical coordinates for x and y. Okay, I think one example it's enough to showing that if functions are one-to-one, the function and its inverse is symmetric with respect to the line y equal x. Okay, next we're going to talk about how to find the inverse function algebraically. So I'm going to review the steps of finding the inverse. The inverse of one-to-one function. So inverse of one-to-one function, you're finding exactly the same way like inverse of any type of function. What we're going to do, we're going to take original equations, switch x with y, solve for y, and that will be the equation of inverse function. Okay, so we should know that already, but this is what we're doing first. Step 1, interchange the variables x and y. Step 2, solve the new equation for y. Step 3, here, since we're dealing with one-to-one functions, so you always have a chance to check your work. So I recommended to do that. Step 3, check your work. Which means by showing that your original function composed with inverse will give you x, and inverse function composed with original also has to give you x. If you have a time to do it, I always recommend it to do it, especially on a test. Okay, so let's do some examples. Again, going back to your textbook, this is page 421, number 53. So what you need to do, a couple things which they ask you to do, okay, A and B. So in part A, they ask you to find the inverse of the function f of x with given equation 4x plus 2, which definitely it's one-to-one. And B, they ask you to find the domain and range of f of x and its inverse. Okay, so let's start with original function. So f of x, the original function for x plus 2, this is the straight line. So what you guys know about the straight line, you know the domain, which is our x values, are all real numbers, which is from negative infinity to infinity. Range of linear function, it's also no restriction, which means from negative infinity to infinity. So this is function f of x. Next, what we need to do, we need to find the inverse. So find inverse. So what we're going to do, f of x technically it's the same as y. So we have y equal 4x plus 2 as our original function. We're going to switch x with y. So what used to be y will become x, and what used to be x will become y. Okay. Now, when you switch, solve for y. So I will subtract 2 from both sides, and we're getting x minus 2 is equal 4y, and just divide each by 4. And that will give you that y is equal x over 4 minus 2 over 4, which is the same as 1/2. So the new equation, when you solve for y, this is our inverse function. Okay, that's our inverse function. So what I did, I followed the steps which I just gave you. I interchange x and y. I solved the new equation for y, which is right here in orange. And step 3 will be check your work by showing that original function composed with inverse is equal x, and inverse composed with original will give you x. So I will just quickly check work. Check if f composed with inverse equal x, and inverse composed with original also give you x. So f composed with inverse. Okay, inverse function has an equation of x over 4 minus 1/2. So function f is outside. Function f has an equation right here, 4x plus 2. So we have 4x plus 2, and you're going to replace x with the inverse. Okay. Okay, let's simplify that. So we're getting 4 times x over 4 plus 4 times negative 1/2 plus 2. So I distribute 4 to both. That will cancel. We're getting x. 4 times negative 1/2 will give you negative 2 plus 2. They will cancel, so definitely we're getting x. Next, I'm going to check if inverse composed with original also is equal to x. So inverse composed with original function has the equation for x plus 2. So our inverse function has the equation x over 4 minus 1/2. So x over 4 minus 1/2, and where we used to have x, we plug in function f. So we're getting 4x plus 2. Okay, let's simplify that. So we're having 4x plus 2 divided by 4. So you can split that fraction. This is the same as 4x divided by 4 plus 2 divided by 4 minus 1/2. So here we're getting x. 2 over 4, it's technically 1/2, minus 1/2. They will cancel, and we're getting x. So definitely, we solve that correctly. We find the inverse function. So now when we find, so here, everything below it was just checking work. Okay. If you guys confident about your algebra, it's up to you if you want to check. I just show you how to check. Okay. Now what they ask you in that problem, they also ask you to find the domain of inverse. So domain of inverse, it's equal to range of original function, which we find it already. It was all real. So I'm just going to copy it from negative infinity to infinity. Now, range of inverse, by definition, tells you that this is the same as domain of original function. So domain of original function, it was all real from negative infinity to infinity. So I just copied that. But also, for some reason, if you missed that information, your inverse function right here, it's linear function. So for linear function, domain and range, it's always all real. Okay. And I think we good here. And I will just do one extra example. Very small example to this one. Here they're going to ask you of finding inverse of domain restricted functions. So to be able to find the inverse, your function has to be 1-to-1. Like y equal x squared, let's say it's a quadratic function, right? Which is not 1-to-1. So I just want to quickly explain it. But I really want to find the inverse of that function. So what you guys can do, you can always restrict the domain to make it 1-to-1. So let's say you can only focus on this part. And you will say, okay, I'm restricting domain for x's greater than 0, which means from 0 to positive infinity. And now, if we know that we're talking actually about the right side of quadratic function, you make that by restricting domain 1-to-1, and you can find the inverse. Okay, so let's just do one example when we had to restrict the domain to be able to make the given function 1-to-1. So find the inverse of function f of x, which is equal x squared minus 4 over 2x squared. So this function, again, if you won't restrict the domain, it's not 1-to-1. So you can't find the inverse. However, we're going to restrict the domain such that, and let me just erase that because that's not the graph. I don't want anybody to confuse this one. I was just explaining. Such that x is greater than 0. So what that means, I restrict the domain and I'm only working with the domain from 0 to positive infinity. So restricted domain of original function. Okay, so domain of original function is from 0 to positive infinity. What will be the range of f of x? I don't know. Okay, for example, let's say I will pretend that I don't know. So I will leave that for now. Okay, maybe if I will find the inverse, I'll be able to find the range of original function without graphing. So we'll go back to that. So let's find the inverse. Okay, so we follow those 3 steps. I will just follow 2 steps. I will leave checking for you guys. So f of x, again, is the same as y. So we have a function y is equal x squared minus 4 over 2x squared. Find the inverse. So first we going to interchange the variables. What used to be y will become x. What used to be x will become y. So we have y squared minus 4 over 2y squared. Now we're going to solve for y. Okay, so x equal y squared minus 4 over 2y squared. To solve for y, multiply all by 2y squared. Okay, so let's simplify. So we end up with 2y squared x equal y squared minus 4, and now you need to solve for y. So I'm going to solve for y squared. I will subtract 2y squared x from both sides. So that will give me 0. It's equal y squared minus 2y squared x minus 4. And I will move 4 to the other side by adding 4. So we have 4, it's equal y squared minus 2y squared x. And isolate y squared. That will give us, factor out y squared. So that will give you 1 minus 2x. And divide all by 1 minus 2x. And we're getting y squared, it's equal 4 over 1 minus 2x. And now we just need to take the square root of both sides. So we're getting y, it's equal square root of 4 and square root of 1 minus 2x, which is 2 over square root of 1 minus 2x. Your textbook left the solution that way, okay? I'm not sure how my MATLAB wants you to keep the solution, but I teach you guys one extra step that usually we don't keep product on the bottom, so you should multiply top and bottom by 1 minus 2x, square root of 1 minus 2x. We should rationalize that denominator, and that will give you 2 square roots of 1 minus 2x over 1 minus 2x. Okay, I just want to explain it again that your textbook left the solution that way. So I'm assuming that my MATLAB maybe won't ask you to simplify that further. Okay, so this is the inverse function, so I will just follow the book. Okay, the inverse function, it's 2 over square root of 1 minus 2x. Okay, so let's talk about it. Couple things here. Okay, we definitely here need to talk about the domain of the inverse function. So look what happened. You have a fraction, so we know that you cannot divide by 0, and also you have a square root. So what you know about the expression under square root? That it's greater or equal to 0. Okay. However, since that square root, it's in denominator, so it can't be equal 0, because then we're doing that illegal algebra, we're dividing by 0. So just give the condition that 1 minus 2x is greater than 0. Let's solve for x. Okay, so we subtract 1 from both sides, and we're getting negative 2x greater than negative 1. Divide each by negative 2, and then you're getting that x is less than, because we're dividing by -2, we're switching inequality, 1/2, which means domain of the inverse is x less than 1/2 it's from -infinity to 1/2. Okay, so I will stop for a second. Domain of inverse, by definition, it's equal to the range of original function. So I'm not sure if you guys still remember, but I left the range of original function. I didn't solve that. Okay, I wasn't sure what was the range of original function. So now when I have an inverse, I know the domain of my inverse function is the same as range of original function. So I know that the range of original function will be from -infinity to 1/2. Okay, so sometimes if you don't have, you're missing some of the information, just leave it. Okay, when you find the inverse, you will be able to quickly verify. Okay, and now I need to figure out what is the range of the inverse function. So with range, it's always more tricky because technically you should graph the function, see it. But since I know the fact that range of inverse is the same as domain of original function, and we already find the domain of original function, which was, and it was given from 0 to +infinity. So that's my range of inverse, which is from 0 to +infinity. Okay, so that's how I can use help from inverse to fill up the range of original and the range of inverse. That's it of section 6.2. Hopefully that helps with studying, and soon you're going to see 6.3. Okay, thank you for watching.